Chapter 12. Air and Water. Introduction to the chapter. Air and water are essential for life. We mainly use air for breathing and water for drinking. Without air and water, there would be no life on the earth. Air and water have different properties. Let us study about them. Atmosphere. Air supports life on the earth. It forms a thick layer around the earth. This layer is called the Earth's atmosphere. This atmosphere extends to hundreds of kilometers above the earth. Layers of atmosphere. The atmosphere has the following layers. Troposphere. The layer closest to the Earth's surface is called the troposphere. It extends up to 15 kilometers from the ground. It is the thickest layer. All the weather changes take place on this layer. The living beings live here as plenty of oxygen is available for breathing. Stratosphere. Stratosphere forms the next layer. It extends from 15 kilometers to about 50 kilometers from the ground. It has the ozone layer which protects the Earth from harmful ultraviolet (UV) rays of the sun. The jet planes fly in this layer. Mesosphere. Mesosphere lies above the stratosphere. It extends from 50 kilometers to 80 kilometers above the ground. Many meteoroids burn up in this layer when they enter the Earth's atmosphere. Thermosphere. Thermosphere is the fourth layer. It extends from 80 kilometers above the Earth's surface to outer surface. Here temperature increases with height and can rise to as high as 3000 degrees Fahrenheit. This layer is known as the upper atmosphere. Space shuttles orbit the Earth in this layer. Exosphere. Exosphere is the last layer of the atmosphere. The air here is very thin. Beyond the exosphere is a vast, empty space. There is no air in this space. Artificial satellites orbit the Earth in this layer. Some of the ways in which the atmosphere is useful for us are: it keeps the Earth planet warm. It provides you air to breathe. The ozone layer in the atmosphere absorbs the harmful ultraviolet rays of the sun. The atmosphere helps in recycling water through the water cycle. Composition of air. Air is a mixture of several gases. It contains many gases that are useful to plants and animals. The main gases that are found in air are nitrogen, 78%, oxygen, 21%, and the remaining 1% comprises a number of other gases such as oxygen, neon, carbon dioxide, etc. The amount of water vapor present in the atmosphere is called humidity. In areas where it rains a lot, there is more humidity in air as compared to dry areas. Air also contains dust and smoke. The excess amount of these pollutes air. Smoke and fog combine together to form. Smog prevents us from seeing the sky clearly. Properties of air. 1. Air takes up space. Activity 1. Take a balloon. Blow air into it. When we blow air into it, it gets inflated. This is because air occupies space in it and it grows in size. Similar examples are air in footballs, vehicle tires and cushions, etc. 2. Air has weight. Activity to an inflated football, balloon or cushion weighs more than a deflated football, balloon or cushion. It shows that air has weight. 4. 3. Air supports burning. Activity 3. Air consists of oxygen that supports burning. Take 2 burning candles and a glass. Cover one of the burning candles with glass. Now wait and observe that the covered candle stops burning after some time. The candle goes off as it does not get air to burn. 4. Air exerts pressure. Activity 4. Take a glass filled with water up to brim. Put a cardboard on the top of glass, press the cardboard firmly and turn the glass upside down. Remove your hands. You will see that cardboard does not fall off and water will not flow out. If there was no air pressure, we would not be able to do following things: drinking through a straw, filling up a syringe, using droppers, filling up fountain pens. Water. Other than air, water is the most important substance needed by living beings. Life on the earth is not possible without water. We need water for many purposes such as drinking, cooking, etc. Plants also need water to prepare their food. About 70% of the Earth's surface is covered with water. Water fills the oceans, seas, rivers and lakes. It is also found inside the crust of the earth as groundwater. Impurities in water. Rainwater is the main source of water on the earth. It is considered as the purest form of natural water, but as it reaches the earth's surface, it dissolves various impurities from the air and from the ground. These impurities are of 2 types. 1. Soluble impurities. Impurities like salt and chemicals dissolve completely in water. They are known as soluble impurities. 2. Insoluble impurities. Impurities like sand and mud do not dissolve in water. They are known as insoluble impurities. Removal of insoluble impurities. Insoluble impurities in water may be removed by following processes. 1. Sedimentation and decantation. 2. Filtration. 1. Sedimentation and decantation. This process involves the following steps. The mixture of insoluble impurities, for example, mud and water, is allowed to stand undisturbed in a beaker. After some time, the mud settles down at the bottom of the container as sediments. This process is called sedimentation. Clean water can then be poured out into a separate container without disturbing the sediments. This process is called decantation. 2. Filtration. In this method, insoluble impurities can be removed by passing the impure water through a filter paper. A mixture of sand and water can be separated using filtration. A circular piece of filter paper is taken and folded twice to make a cone. This paper cone is kept inside a funnel. A flask is kept below the funnel and the mixture is poured into the flask through the funnel. Sand is retained in the filter paper and clean water is obtained in the flask. Removal of soluble impurities. Most soluble impurities can be separated using following processes. 1. Evaporation. 2. Distillation. 1. Evaporation. It is the process of converting a liquid into vapor. Water containing insoluble impurities like salt is heated. Water changes into water vapor and escapes, and the impurities are left behind. 2. Distillation. This process can be done on a small scale in a distillation flask. When impure water is heated, it starts boiling and steam is formed. This water is free of impurities as they are left behind in the distillation flask. Pure water is collected in the collector. Purifying water at home. Impure water contains disease-causing germs. Drinking water can be made germs-free, pure, by following processes. 1. Boiling. The best way of purifying water to remove bacteria and germs is boiling. You should boil water for about 15 to 20 minutes. 2. Chlorination. The process of adding chlorine in water to kill germs is called chlorination. Chlorine is commercially available as tablets.